Thanks a lot for coming to see us. So my name's Phil Chambers, and I'm from a company called Orbex. We are a Scottish rocket launch company with a subsidiary in Denmark. I'm going to talk you a little bit through the sort of foundational journey. You heard Sabina in the last talk talking about how hard space is. I can certainly attest that that is true. We're going to talk a little bit about our origin story and where we came from. So first I'm going to take you back to a British pub. A group of 5 friends sat around in 2015 drinking pints. When I was practicing this, my colleagues pointed out that you might not know what a pint is. So it's a 568 milliliter glass of beer. They were discussing the idea of putting a spike in the moon and how they might be able to do that. So it turns out that this is a bit of a wild idea, a bit of a silly idea, but they decided to push on with it, and they decided to try and crowdfund this company called Moonspike, which was about seeing if this was possible. And it turns out that it's not, at least not possible to crowdfund. But that conversation led to something bigger. It led to them asking a few questions around, well, why isn't it possible to launch satellites? Why is it so hard? And what would it take to be able to do that in the UK? So what they discovered would set them on a new course entirely. And that was that there was actually quite a big gap in the market. So Europe was building satellites at an increasing pace. You had successful companies like Airbus, like OHB, many small companies. You know, there's a whole ecosystem in Glasgow. And yet, there wasn't really anywhere in launch to launch them. Ariane 5 was a super heavy launcher, extremely reliable, but extremely expensive. So small satellite companies were being held back by a lack of access. Compounding this, Europe's problems continued when, SpaceX came around. So Ariane 6 was the answer to that. It was supposed to dramatically reduce the cost of access to space for Europe. In fact, the vehicle has been successfully launched, but it also needs massive subsidies to work. And then we had the failure of Vega as well. So we were left at a period of time where Europe had absolutely no access to space at all. Of course, over in the US, that wasn't true. Back in 2006, NASA had started this thing called the COTS program, Commercial Orbital Transportation Services. And this was the idea of opening up for the first time the government market for launch contracts and defense market to private companies. Of course, I don't need to tell you the whole story of SpaceX, but they have obviously been incredibly successful with their new space approach. You saw some of those pictures of Falcon 1 in the previous presentation, but a very different company now. But of course, with SpaceX building bigger and bigger rockets, and you want to launch small satellites, you end up having to go on what we call ride-share missions, which are very cheap, but they don't give you necessarily the orbit that you want to go to. You can't be the prime contractor. You can't go at the time you want to go. So that's where the idea of building a small launcher came from, and that's where the birth of Orbex came about. So we are a European orbital launch services company headquartered in northern Scotland, 45 minutes outside of Inverness. It's a very beautiful place on the Moray Firth if you've not been. We also have our propulsion factory in a place called, and apologies to any Danes in the audience, Villeroi. And our vision is to build sustainable launch transportation services for the good of humanity. So we're building rockets, but not just any rockets. And the demand for this has never really been higher because satellites, of course, today underpin every part of modern life, from communications to navigation, agriculture, etc. And the demand for satellite data services is now growing exponentially. So this year, valued at 10 billion plus, by 2031, in 6 years' time, that's forecast to double. So it's a 16% annual growth rate. And why is that? Well, the Earth observation use cases are manifest both in mitigating climate change, but also in other domains. We see that in the Ukraine. Disaster response relies on real-time satellite data. Precision agriculture, now, you have John Deere tractors driving all over the place using satellites to navigate. And of course, we've seen, unfortunately, in the Ukraine war, that war change from a war of heavy artillery and jets to now a war of drones, and drones that only work with both communication systems and navigation systems to target them. So this, of course, has led to an explosion in the demand for launch. Forecast to go from 13 billion to around 36 in the next 10 years. And 17,000 satellites are expected to be launched over that period, so averaging 1,700 a year now. To put that into perspective, by 2032, they think there'll be 4 tons of satellites a day being launched into orbit, and that satellite market will grow to about 100 billion a year at that time. So it's absolutely massive. And that's why we believe Europe needs companies like Orbex. So we've grown from an idea 10 years ago to a team of 250 world-class rocket engineers, mission specialists. We're a highly vertically integrated company, so we're building everything from avionics to software to structures to engines. We've got critical support from VCs, also public bodies such as the UK Space Agency, ESA, and the UK government, which recently invested in us. But something else has shifted too, and that is obviously the geopolitical landscape. I think more than ever, Europe now sees the strategic importance of having its own access to space, particularly with increasing regulatory friction in the US. A side effect of the tariffs, which are sort of up and down every week now, is that, of course, satellites have to be imported to the US in order to launch them, so therefore would attract tariffs. And the fallout from Ukraine has shown how fragile our space supply chain can be when you have people like Musk who can threaten to turn off Starlink just like that. So we believe that Europe can no really longer rely on others for access to space. So what makes us different then? So we've designed our Prime micro launcher from the ground up to be a new generation micro launcher. We have not just copied old 1960s technology, but we've looked at every single part of this vehicle and how we can make it better. So firstly, the entire structure is built around our novel coaxial tank. So we've built the world's first linerless carbon fiber coaxial tank. You can see a sort of schematic diagram of that. This allows for 30% less mass than a sort of traditional stack structure, and you get built-in thermal management. So you can see the liquid oxygen is a jacket for the propane, which allows you to densify the fuel and get more propellant on the rocket. We also use additive manufacturing. So it's not just as simple as 3D printing an engine. There are quite a lot of nuances in using different superalloys inside 3D printers. But it allows you to create very complex structures in one piece. There are 128 cooling channels in those engines that you can see on there, and none of them have to be brazed or welded. They come straight out of the printer like that. We've also designed our vehicles to be as almost carbon neutral, so to reduce the carbon impact as much as possible. So we architected the whole microlauncher to run on biopropane. That is a byproduct of biodiesel production, has 96% less CO2 emissions over the life cycle, and critically also doesn't emit black carbon or soot, such as a standard kerosene rocket would, into the high atmosphere. So we aim to be the world's most environmentally friendly launch provider, and to leave, of course, critically no debris in space. And we've also architected our microlauncher to be reusable. Normally very, very difficult with a vehicle of this scale to do this because you can't carry excess propellants on board. But we've built this novel petal system. So as you can see, the interstage opens up like the shuttlecock, slows the launcher down from hypersonic speeds, and allows you to capture it with relatively small parachutes for first stage reusability. So what's next? We are about to scale for the future. Our ambition, of course, is not to just launch one rocket, but to build a high-volume manufacturing facility. You can see the sort of design for it there, to support commercial operations after our first test launches. And it's a very, very exciting time in Europe now because Europe is now investing. We are 1 week away approximately from the end of the tender process for European Launch Challenge. Now, ELC is a European Space Agency initiative to effectively do what NASA did in 2006 with the COTS program for SpaceX for European launches. So Orbex and others in the industry are bidding for tickets into this competition, and there can be more than one winner. Each one can subscribe for 169 million euros of development funding, plus very, very importantly, institutional contracts with both ESA missions and the European Union. So we really think this is an amazing initiative to kickstart the next generation of European launches. And so with that, I'm really happy today to publicly unveil to you the first renderings of our next launcher, which is called Proxima. So Proxima is here. This is a medium-class vehicle capable in its initial configuration of launching 8 tons to low Earth orbit, but also capable of a lot of different mission classes too. So this is a vehicle that can go beyond low Earth orbit, can launch medium Earth orbit satellites around 20,000 kilometers, can do geostationary missions around 36,000 kilometers, and can take payloads to the moon and carry capsules and what have you. So that is Orbex Proxima, which is our next product. So people often ask me why I got into this. You know, I had a 20-year career in software, but I think back to when I was a child. This is not a picture of me. This is an AI-generated image of a child, because I didn't have any photographs of me with a telescope. But indeed, that is something I was doing as a kid, was looking at the stars. I'm old enough to remember the Challenger disaster, and I've got several books on that. I was kind of absolutely in awe of the space shuttle program. So when I graduated from Manchester, I went straight along to the sort of Airbus recruiting stand after doing my Erasmus year in Toulouse and said, right, I'm ready to come and work for you guys. And they said, well, we're not hiring computer grads. So I ended up with a varied career in software. After selling Peakon to Workday in 2021, I started doing some angel investing, and one of the companies I invested in was Orbex in 2022 in the Series C. And then the very next year, the opportunity came along to join as CEO, so I sort of thought, do you know what, I couldn't imagine a more interesting job in European technology than running a space rocket company, because I truly believe this is one of the most important and strategic things that we as Europeans can do. So the good news is you too can also join the journey. So we are also looking for world-class engineering talent to join the company. We're looking for customers, and of course we're also always in space looking for new investors. So thanks a lot for listening today. Hope you enjoyed the chat, and I will see you at the conference. Cheers.